So we'll calculate the similarity of the nodes in this graph using the SimRank algorithm. Now the basic concept is that the similarity of any node with itself is 1, and initially we can assume that initially we can assume that similarity of any node with any other node is 0. So with itself it is 1 and with others it is 0. And then for further calculation we'll use this formula of SimRank, which is, normally we write the iteration number as subscript. So this is, let's say, S0, and for iteration 1 onwards we'll calculate the similarity between A comma B. Okay, so the condition is, if in degree of A comma in degree of B, if they are not 0 or they are not empty, basically IA and IB are the in neighbors of A and in neighbors of B. So if they are not empty, then we can calculate the SimRank as C, which is the decay factor divided by the cardinality of the in set of A multiplied by the cardinality of in set of B multiplied by summation over all I belonging to the in set of A, summation all j belonging to the in set of B, S naught of I comma j. Okay, and if for any one of them, like if either IA or IB is 0, if it is that is, if I or IB is empty, basically if there are no incoming nodes for any particular node, then for that pair the SimRank cannot be calculated. So it will be 0 otherwise, if either one of them does not have any incoming nodes. So this is the basic calculation. Okay, this was our graph. So now what will remain constant in all the iterations is the IA or the incoming set, basically in neighbor set. So for IA it is phi. The in neighbor set for IB will also remain constant throughout our calculation. What are the in neighbors? There are incoming nodes towards B from A and D. So A comma D. For node C, the nodes from which we have the incoming arrows or incoming connections, those are A and B. For node D, we have incoming from C. That's the only incoming arrow or incoming edge towards D, right? So these are all the in neighbor sets. Now let's calculate the SimRank for all the pairs one by one. Let's calculate S1 of A comma B. Now it will be, now we'll assume the decay factor C as 0.8. If it is not given in the question, you can assume it as 0.8. Okay, normally 0.6 to 0.8 are the values which we take for C. Let's take it as 0.8 in this case. Now, can it be calculated? It cannot be calculated because one of them, that is A, has an empty in neighbor set. So therefore, the cardinality of IA will be 0. Okay, so for the first iteration this is 0. Now similarity of, let's say, next we'll calculate B comma C. For B comma C, decay factor is 0.8. C divided by cardinality of B, which is 2, into cardinality of C, which is also 2. Okay, then summation of SimRanks of all the pairs S naught Ij. What does that mean? Now I belongs to IB and J belongs to IC. So that means you'll have to combine A with A. Okay, the combinations that you will consider are A with A. We are considering these two, right? Because we are considering B and C. Okay, so A, we are basically calculating the sum of all this. A with B, DA or AD, and DB or BD. These are all possible combinations of the in neighbors of B and C. Now this is 1 because it's the same node. For all others it will be 0. Okay, because this is 0 because A, basically A has no in neighbor, so it will be 0. Okay, now for DB also, in case of DB, if you calculate the similarity S0 of DB, initial assumption as we had written over here, initial assumption, initially S0 xy is anyway 0, right? So yes, because it is S0, not because A has an empty in neighbor set. In this case, this will be 0 because it is S0, the 0th iteration. And in 0th iteration, we anyways assume that if we are calculating for x comma y, then it will be 0, and only for x comma x it will be 1. That is for the 0th iteration. So therefore, it will be 0.8 divided by 4, which is 0.2. Okay, and then S1 of, similarly we'll calculate for, let's say, C comma D. For C comma D it will be 0.8 upon, for C we have 2 in neighbors, D we have 1, and the combinations will be S0 A comma C plus S0 B comma C. So it will be 0, right? Because it is 0 plus 0. Then for S1, okay, so we have covered this direct connection AB. Okay, let's cover the connection AC as well. We covered AB, we covered BC, we covered CD. Let's cover AC as well. For AC, it will be again not possible because empty set, A has an empty set, so it will be 0. Okay, so I hope this procedure is clear to you. Let's take another example. Let's say you have this graph. You can pause and calculate all the SimRank values for yourself, and then you can verify the answers. So the first step is you'll calculate the in neighbor sets. Right, and then S1 of, say, A comma B, 0.8 upon, assuming C, decay factor C, assuming it is 0.8, so 0.8 upon 1 into 2, cardinality of IA into cardinality of IB, and then the sum of S0 of B comma C. In fact, if you can see, if there is no commonality between the in neighbor sets, it is always going to be 0 because our S0 assumption is 0 for x comma y pairs. Then S1 of okay, what other pair should we take? Let's say AC. This will be 0 because C has an empty set. Let's say S1 of AD. For AD, again, see, as per the observation, like yes, you can proceed like this will be 1 into 1. But then as you can see, for AD, the only pair we create is BC, and because there is nothing in common, it is x comma y type, therefore it will be 0, right? Now the only non-zero value I think you will get is when you combine B with D, like when you try the pair B comma D. So in this case it will be 0.8 upon 2 into 1. IB has cardinality 2, ID has cardinality 1. Now here you have C comma C combination because there is C over here and C over here as well, and then you have S0 D comma C, which is anyways going to be 0. So here the answer will be 0.4. 0.8 divided by 2, which is 0.4. Okay. Similarly, if it is asked in the question, you can continue with the further iterations as well, but mostly one iteration will be sufficient. I hope this was clear to you. In this case, even if we go for the second iteration, BD pair, so A comma B will get updated. If we go for the second iteration, S2 of A comma B, let's say I'll solve it here itself. Let's say I calculate S2 of A comma B, it will be again, this part will remain constant, okay. B comma C, so B comma C is 0 anyways because C has an empty set, and B comma D, so B comma D has a value of 0.4, right? So this is 0.4 times 0.4, which will be 0.16. In iteration 2, the similarity of A comma B is 0.16, okay. That's it. If you have any questions, any doubts, do post them in the comments below.